All right, folks, so now we're actually going to get to this whole adding and subtracting of the rational expressions. Now, when we're adding and subtracting fractions, we have to have a common denominator. Now, that common denominator is going to be your least common multiple. So when we did this problem, we've actually already found our common denominator. We did that previously. And we said that the least common multiple here was going to be 3 times 3 times 3 times 2, which was 54. But you'll see that I'm actually going to work with the prime factorization a bit to explain this. Now, I know you guys have added fractions before, but I want you to see the connections between when you are dealing with the rational numbers and when you are dealing with the rational expressions. So, this is the problem that I currently have. Now, the first thing we did is we factored out our denominators and we looked to see, hey, what's going to be my least common multiple? And we said it would be 54, and then that was the factorization of that. Now, what I want to be able to do is I want to be able to take this expression and I want to be able to rewrite it so that my denominators are in fact this least common multiple. So I'm going to go ahead and I'm just going to do that. Now, then I start to kind of ask myself a bunch of questions. So my first question is, well, when I compare this first denominator to my LCM, what am I missing? What does my LCM have that this denominator does not have? And it's 2. So I'm going to end up having to multiply my numerator and my denominator by 2. So my denominators now match, so now I actually know I have 10 in my numerator, because I can do the 5 times 2. Well, I then know if I need to try to get from my original denominator to the LCM. Well, now when I compare these, I can see that I'm actually missing a factor of 3. So I would have had to have multiplied my denominator by 3, so now I'm going to have to multiply my numerator by 3. So 13 times 3 is 39. Well, now my denominators are exactly the same. So I can rewrite my denominators as 1, and then my numerators could go together as 10 plus 39. So I know I'm going to end up with 49 over 54. Now, yeah, it would have been a lot easier to put that into the calculator, but I want you guys to kind of see how this is done with the prime factorization when we're dealing with these integers as our denominators. So now what we're going to do is we're going to take a look at another example. I'm kind of going to skip around a little. Now, in this example, obviously now I'm dealing with my polynomials in my denominator. Now, when I'm going to go look for that least common multiple, the first thing that I have to do is I have to factor my denominators. So, when I go to factor my denominator, now I'm dealing with 8 over 3 times x minus 2. Freshmen are done eating lunch. Plus 5 over x plus 1. Now, this whole x plus 1 is the factor. So when I go to look for my least common multiple, nothing is shared amongst them. So what ends up happening is everything is considered a leftover. So my least common multiple is this. Now, I always write it out like that. 1, if you don't get it right, but you do it all with the wrong LCM, you're going to get a little credit. And it also gives me my goal. I know that my goal now is to get each of these denominators to be that. So I write it in. That's where I'm trying to get to. So then I say to myself, well, when I take a look at my original denominator, what am I missing that this one has? Well, it's this x plus 1 that's missing. So now I know that I would have needed to have multiplied my numerator and my denominator by x plus 1. So my numerator now becomes 8 times x plus 1. And then when I compare the second denominator to my LCM, well, I have the x plus 1, but I'm missing the 3 and the x minus 2. So 5 times 3 gives me the 15, so I have the 15 times the x minus 2. So now I have the same denominators, and I've brought down my numerators. At this point, you guys have to simplify the numerator. There is absolutely no canceling that is taking place here. I'm not going to cancel those. I'm not going to cancel those. I'm going to end up right back where I started if I do that. But I can see that if I take my numerators now and I simplify them, I end up with 8x plus 8 plus 15x minus 30. Well, I can combine my like terms. So I end up with 23x minus, whoa, sorry guys. I'm getting a phone call on my Apple Watch right now, and then it distracted me. Minus 22. Okay, all over that common denominator. Now, if you can factor your numerator and you can tell that something would cancel, go ahead and do it. But if you can tell nothing's going to cancel, I don't really care if you factor it. But do not multiply your numerators back together. So this is now what that sum of those two rational expressions would be.